Hello, Chem 1. Now that we've talked about the history in 5.1, we're going to start talking a little bit about the basic arrangement of the periodic table and how it's organized. Let's get started. First, let's start off with some things you should already know because we've already gone over electron configurations. You know that the periodic table is divided into blocks. The first block is the S block, which can hold 2 electrons. P block can hold 6 electrons because there are 3 orbitals in a p sublevel. D block is the transition metals. And then F block is down here at the bottom, which can hold 14 electrons because there's 7 orbitals in an F sublevel. Typically, these columns have similar properties because of their similar electron configuration notations and their same number of valence electrons. A lot of the columns also have proper names like alkali metals and noble gases. Just a quick review, there are 7 rows on the periodic table. Those rows are called periods or series. Those rows would also indicate how many energy levels are around the nucleus. So for instance, in the first row, helium and hydrogen have their nucleus and only 1 energy level around it because they only need the 1 energy level to fill those 2 electrons. The second energy level, or the second period, would have all those atoms would have 2 energy levels around the nucleus, and so on all the way down. One way to divide up the periodic table is into metals, nonmetals, and metalloids. Metals are typically shiny, which means they're lustrous. They're typically good conductors, and they typically can be hammered into thin sheets or drawn into wires. Metals are typically on the left side of the periodic table. Nonmetals are typically on the right side of the periodic table, on the right side of what we call the stair steps of the metalloids. They're typically dull and brittle. They don't conduct electricity very well, and they typically have 5, 6, 7, or even 8 valence electrons. The metalloids are what's bridging the gap between the metals and the nonmetals. We have a stair step on the periodic table that starts at boron and goes down and to the right. Let's take a look at that now. So if you look, here is boron. It is one of the metalloids, and if we start drawing a stair step here, you can see that there's kind of a dividing line between the metals, which are blue in color here, and the nonmetals, which are green in color here. Notice we do have a nonmetal, hydrogen, that's on the left side, and that's because it has 1 valence electron, so it's kind of out of place, but it's still a nonmetal. Another thing to remember is when we draw this stair step, aluminum and polonium are not included in that stair step. Those are typically considered metals. Metalloids typically have characteristics of both nonmetals and metals. Sometimes they're called semiconductors because they're kind of in between. Before we get started with the names of the families, let's talk about a couple other locations on the periodic table. We have the transition metals, which are here in the middle between S and P block, which is the D block. And then the F block actually has series names. So the lanthanide series is the top row of the F block, and the actinide series is the bottom row. The reason we call them that is because the first element of the lanthanide series is lanthanum, and the first element of the actinide series is actinium. Typically, these transition metals are fairly stable, and a lot of times they're used for things like jewelry or building materials because they're not very reactive. But when you get down to the lanthanide and actinide series, you can get into some radioactive elements. All right, let's talk about the S and P block families. The first thing we need to talk about is hydrogen. Hydrogen is in the first column, but it's not really representative of the alkali metals, which is what the first column is named. Hydrogen can behave like a metal in that it loses electrons, but it can also gain electrons and behave like a nonmetal. It is also the most abundant element in the universe and typically found in stars. Now that we've dealt with hydrogen, let's talk about the first column of the periodic table. The first column is called the alkali metals. It has 1 valence electron. It has things like lithium and sodium and potassium. Lithium, you know, is used in batteries, typically good batteries. Sodium and potassium are really important to our diets. And also, alkali metals are very reactive. They will react in air and they will react violently in water. This is why, as you'll see in the picture, that we typically store these in mineral oil, and that's so they don't come in contact with the air. It gives them a coat of oil around them, and they're not likely to react. Group 2 is known as the alkaline earth metals, so that can be confusing. Group 1, alkali metals. Group 2, alkaline earth metals. We have beryllium and calcium, magnesium. Magnesium and strontium can show up in fireworks because they burn very bright and they also Strontium typically has a red-orange color, which is very common in fireworks. Barium can be used in intestinal testing to trace different things that are going on in your intestine. Calcium is in everything from limestone to dairy foods, essential for your bones and teeth. It can also contribute to hard water. Another element in group 2 is radium. Radium is a radioactive element. It was actually used back in the early 1900s as something that would glow in the dark, and they used to paint it on watches and other pieces of jewelry that could glow in the dark, and everybody thought it was really fancy. What they didn't know is it was giving them cancer. You can Google the term radium girls, and you'll find stories about women who during wartime they wanted to produce watches for soldiers so they could see the face of their watch, and so they'd paint radium on the numbers and the hands of the watch. Well, it's a really tiny surface to paint on, and so what they would have to do to make a sharp paintbrush is they would lick the paintbrush. Well, when you're painting with radium, that's not a good idea. And all these cases of cancer were produced because we didn't know enough about radium at the time. If you look here at the periodic table real quick, we've covered column 1, which is the alkali metals, column 2, which is the alkaline earth metals, and now we're going to skip the transition metals and work at 3, 4, 5, 6, 7, and 8. These are what we'd call the main group columns. Transition metals would not be a part of that main group. So if we skip all the way over to group 13, also known as main group 3, we get something called the boron group. The boron group is the first group where we see metalloids, boron. Boron can be used in borax, which is a detergent. It can also be used in boron fiber, which was a precursor to carbon fiber. Aluminum is also in this group. Aluminum is super important to our society in terms of cans and foil and all kinds of uses, even like lightweight golf clubs and bike. Aluminum is the most abundant metal, not element, metal in Earth's crust. It's third overall in the Earth's crust. Gallium is really important. It's used in computers. It has a really low melting point. You can melt it in your hand. A lot of times gallium is a great conductor to use when you're building a processor and you're trying to dissipate heat. Group 14 is the carbon family. Carbon is really important to us in our life because a lot of the molecules that make me and you up are made from carbon. Carbon is a great building block. It's a great Lego because it has 4 bonding sites. Everything in this group does. Silicon is the second most abundant element in Earth's crust. That's because quartz and sand are made mostly out of silicon dioxide. Lead is also in this group, and so is tin. One thing you'll notice about this group is it goes from carbon, a nonmetal, all the way down to lead and tin, which are metals. So it's starting to span the gap across that metalloid staircase. Group 15 is the nitrogen group. It's also known as the nitrogens. Nitrogen is the most abundant element in our atmosphere, and it's super important for plants to grow and for us to build amino acids. Phosphorus, arsenic, antimony, and bismuth are all in this group. Bismuth is in Pepto-Bismol. Phosphorus is really important for fertilizers, and adenine triphosphate, which is ATP, your energy molecule that's in your cells. And antimony is used in stainless steel. Group 16 is the oxygen group. Oxygen is the most abundant element in the Earth's crust, which seems counterintuitive, like oxygen's a gas. Why would it be most abundant in the crust? It's because of everything oxygen bonds to. Remember, silicon dioxide is a very abundant compound in the Earth's crust. That's 2 oxygens for every molecule. Sulfur is also in this group, and selenium. Selenium is really important when we build solar panels, which are getting cheaper and cheaper these days, more and more affordable. Selenium can also be used in cancer treatments. Group 17 is the first column that is all nonmetals. We have a couple gases and liquids in this group, fluorine and chlorine. Fluorine is in the form of fluoride, is in our toothpaste, but it's also one of the most reactive elements. Chlorine is a poisonous green gas. Bromine is the only liquid nonmetal. Mercury is the only liquid metal. Bromine is the only liquid nonmetal. Iodine is one of the few elemental solids that will sublime. It goes from the solid state and will turn into this purple gas. Iodine can also be used in different types of sterilization or making things bacteria-free. The final group, group 18, is known as the noble gases. They are inert, meaning they do not react. They have full outer valence shells, which means they don't want to bond. So helium is a great thing to use in balloons and blimps because you know it's not going to burn like hydrogen would. There may be a story from history about a blimp catching on fire and burning because it had hydrogen in it before we started to use helium. We also use neon, argon, and krypton. A lot of these are in the neon signs that you see in store windows. Most of them emit a different color from the photoelectric effect, so we can mix them in different ratios and get different colors for those different neon signs. We call them neon signs because neon was the first gas we used in them. Now that we've done the main group elements, let's go back and talk about the transition metals. The transition metals are metals, so they tend to lose electrons. A lot of these metals are magnetic, like iron and cobalt and nickel, and they can even have temporary magnetism if they're paramagnetic. Sometimes it requires us to mine oxides, like iron oxide, out of the ground and then purify the iron in it using a chemical reaction. We use transition metals from everything from jewelry to infrastructure to wiring. This is a very important section of the periodic table in terms of our society and how we use these things. You can see that there's some variation in these transition metals, but most of them are what you would think of when you think of a metal. Shiny, gray, or silver. We already talked a little bit about the lanthanide and actinide series. Just to give you a couple more details, the lanthanide series are silvery with really high melting points. One of the standouts in this row is neodymium because of its very strong magnetic properties. The actinide series, we start to see a lot of our radioactive elements like uranium, thorium, and plutonium. Also in the actinide series, when we get to number 93 and beyond, those are all what we call transuranic elements or synthetic elements. These were man-made in a particle accelerator. Most of them are very radioactive and don't stick around very long before they decay. Hopefully this gives you a general idea of how we organize the periodic table and the names of the different columns and the different groupings. As we proceed through this unit, we're going to start talking about the trends across the periodic table and what we can learn about atoms because of its organization. Good job. We'll see you soon.